Okay, so today we are going to talk about word problems that have to do with separating. So lately we've been talking a lot about word problems that deal with combining things together. You'll see some of those types of word problems still in your written practice later today, but we want to get some examples done today together with word problems that have to do with separating. So the very first one that you see says we've already learned problems about combining have an addition pattern. Okay, so when we write an equation that deals with combining, we will always have a plus sign. But do we use addition to actually solve those problems? If, for example, we have like 25 plus n equals 75, are we actually using addition to solve that combining word problem? No. Okay, you're actually using subtraction. It's called the inverse operation. So if now we are creating word problems about separating, I'm going to have some amount minus some more that went away, and what I have as my answer is what is left over. Okay? So our very first example says Cullen had $28. After he spent $12, how much did he have? So if we have $28, he spends $12, we want to know how much he has. Please write an equation on your whiteboard of what that might look like. Remember, we are writing problems that show separation. So we're not creating addition problems, we are creating subtraction problems. You can pause the video here and try and write your own equation and then check it when you're ready. So you guys have all been showing me your whiteboards. I have seen equations that are written vertically. I have seen equations written horizontally. Every one of you had $28 minus $12. And then what it equals is what we have left over. So I'm going to use an L as my variable to represent what I have left. Okay, you guys went one step further. You solved the problem, and so you knew that Cullen had how much left over? $16 left over. Awesome. Here's another one. Erase your whiteboards. After losing 234 pounds, Jumbo the elephant still weighed 4,368 pounds. How much did Jumbo weigh before he lost the weight? Okay, so think about that very, very carefully. What does that look like? Where does each piece of this problem go in an equation? After losing 234 pounds, Jumbo still weighed 4,368. How much did he weigh before he lost the weight? Pause right here, write an equation you think, and then you can check your work. Okay, so some important things to think about. First of all, Jumbo lost 234 pounds. Okay, so we lost 234 pounds. Jumbo still weighs 4,368 pounds. We want to know how much Jumbo weighed before he lost that 234 pounds. So right here, my W is going to represent weight. Some of you used a different letter to represent that unknown amount. I'm using the weight that Jumbo was before he lost 234 pounds. So this is what your subtraction equation should look like. Now, how do I solve this? You guys were showing me this on your whiteboards first. Your instinct is to start adding the two pieces together to figure out what he started out, or what Jumbo used to weigh. That is exactly how you solve this equation. We're going to take 4,368. We're going to add it to the amount of weight that Jumbo had lost, 234. And when you add it together, you guys knew the answer to this problem. What we were struggling with was figuring out how to write the equation to represent this problem. So the weight that Jumbo was before is 4,602 pounds. Now I can plug that in where W is here. And then I can go ahead and check my work by subtracting 234 from it to make sure that it does in fact equal what it says it should equal. So if I subtract this, I've got to do some regrouping, borrowing and regrouping. I do end up with the same thing that my equation says I should. We're going to do another one. So we're going to practice again. This one says 400 runners started the race, but some runners dropped out along the way. If 287 runners finished the race, then how many runners dropped out of the race? Okay, do we know what we started with? We started with 400. Okay, do we know how many runners dropped out?
Yes. No.
What is 287? Somebody said 287. What is that number representing?
Runners that finished the race.
That's how many runners finished the race. So that's what I end up with, 287. So again, we're doing a word problem about separating. Means I'm going to be subtracting something from the number of runners who started. So I've got 400 minus something equals the 287 that finished. So what am I going to plug in for this blank space here? I don't want a number. R. I like it, Luke. Thank you.
R.
Okay, R for runners. So I'm taking 400 total runners minus the number of runners who dropped out. Okay, that's what the R represents. R represents runners who dropped out. Now, can I solve this problem? Can I solve it?
Yes.
Yeah. How do I solve it? Yeah. Okay, so I'm looking right here at your board and you've got 400 minus 287. Okay, if I take the total number of runners and I subtract the runners that were left over, will it give me the number of runners who dropped out?
Yes.
I hope so. Let's try it. Got to do some borrowing and regrouping. So if we are correct, this part right here should be 113.
Yes.
Okay, let's check our work and see. Let's actually solve this problem and do 400 minus 113 and see if it gives us 287 like it should. Again, it requires some borrowing and regrouping. And does it match?
Yes.
Yes, it does. So we know that we wrote it correctly. We have to change our way of thinking. Very good. You got to change the way you think. Your first instinct is to solve the problem. What we are working on is writing word problems and equations that are subtraction problems.